Probability using cards and diagrams. We're going to go over some basic vocabulary. We'll start off with what is probability. Probability is a numerical measure between 0 and 1, including 0 and 1, that's going to describe the likelihood that something will occur. What we're talking about when we talk about experiments in probability, it's going to be the act of doing something and then noting the outcome. So in this case up here, it's going to be the act of drawing a card. You could be rolling a dice. You could be spinning a spinner, something along those lines. That's going to be known as an experiment. Our experiments are going to have outcomes. Outcomes of an experiment, the results that can occur. And you describe them as specifically as possible. An example is Jack of Diamonds, Jack of Hearts. So that's an outcome. Now we get to an event. What is an event? It's a set of outcomes. Lastly, we get to sample space. What is a sample space? It's a set of all possible outcomes. In this example here, it's going to be the set of all 52 cards. So let's get rid of our little slides. We're going to bring in our video here. I'm showing you, here's a card, deck of cards. You notice how all the cards are the same. Same size, same shape. I'm laying the cards down, showing you that there are 3 face cards. Jacks, queens, and kings. Now I'm going through the number cards, and they are numbered from 2 all the way up to 10. And then these A's I'm about to lay down on the table here are known as aces. So we have jacks, queens, kings, aces, numbers 2 through 10. We're going to start writing these things. You're going to see us write it as, we're going to be writing the probability that we get a red card. We'll notice that you either have a red or a black. So we have a 50-50 chance. So there are 26 red out of 52. We always write this in reduced form. We have a 1/2 chance of getting a red card. Now, as I'm going through here, I'm putting down the suits, and I'm talking about, all right, we have a club, a heart, spade, and a diamond. Each card has one of those, so there's 4 of each type of card. 4 suits, they call those. We start talking about probabilities as I shuffle these cards. If I say, well, what's the probability of getting a 12? And I just showed you that the cards go from 2 to 10. So there's 0 cards out of 52 that have a 12 on them. So that's 0. It's definitely not going to happen. That's what the probability of 0 means. What's the probability I'm going to get a red or a black? As long as I'm using this deck here, it's going to be 52 out of 52, which equals 1, and that's certainly going to happen. Now I'm asking here, I'm putting up a jack. I'm saying, what's the probability I get a jack? Well, there's 52 cards, 4 jacks, so it's a 1 out of 13 chance. Then I'm throwing out there, I'm just looking at the diamond now. I don't care about the number. What's the probability of getting a diamond? Well, there's 13 of them out of 52. It's going to give me 1/4. Then I say, what's the probability of jack and a diamond? Now we're getting somewhere. Well, how many cards are a jack and a diamond? There's actually 1 of those out of 52. Here's where it gets a little interesting. What I'm pointing to there is a jack or a diamond. So let's take a second to think about that. The probability of a jack or a diamond. I'm going to use a Venn diagram to illustrate this. Remember Venn diagrams from middle school. There are 52 cards out of all our cards. We're talking about number of cards right now. We're not really talking about probability. We're going to talk about how many there are. So, out of those cards, how many are jacks? Well, there's 4 of them. How many of them are diamonds? There are 13. And we already established that there was 1 that was a jack and a diamond. 1 jack and diamond right there. So really if there's 1 here, there'd be 3 here, 12 here. Everything that I'm looking for in here is jack or diamond. So the formula goes like this. What I can do when I have this is I do the probability of jack or diamond equals the probability of a jack plus the probability of a diamond minus the probability jack and diamond. So this is my formula, my general formula whenever I'm looking for an OR problem. I do the probability of one of them plus the probability of the other minus the probability of both. So in this particular instance, when I'm looking at something like this, I can simply do this. I can sit there and I can write it as the probability. Well, since they're all out of 52, I can just put them over 52. There were 4 jacks plus 13 diamonds minus the 1 jack and diamond to give me 16 out of 52. 4 goes into both. 4 out of 13 is probability jack or diamond. Now these 2 events, there's something going on here that we have to talk about with these 2 events. These 2 events here were not mutually exclusive. Mutually exclusive means that they have nothing in common. So if I had, well, how many kings and aces, right? Well, these 2 events, since there's no overlap, are going to be called mutually exclusive. You'll hear the word disjoint. And when that happens, I simply have to do the probability of kings plus the probability of an ace. And I don't have to worry about subtracting out the probability of a king and an ace because it doesn't exist. So I could simply add the 2 of them together. And the probability of getting a king is 4 out of 52 plus an ace would be 4 out of 52. So it gives me 8 out of 52. And that occurs when there is no overlap. If I wanted to, I could use this same formula up here. This always works because I could just subtract out the probability of a king and an ace, which is actually just 0. All right, we have one more thing we're going to look at here. So let's go back to our video here. And you'll start to see some of the things that I'm going to be going over. Now I'm going to be drawing 2 cards. So I'm going to clear out a few things from my screen. And here we go, watching my... Okay, so I'm going to be drawing 2 cards. Now I'm going to draw 2 cards from my deck of cards, which means I'm just going to flip one and the other. Here, I'm drawing 2 jacks. So there's 2 different instances that can occur. We're going to talk about independent and not independent events. So we're going to start off with a probability of drawing a jack, put it back into the deck, and then getting a jack on my second card. So that's called with replacement. I put it back, I replaced it. All right, so that's with replacement. And when you're replacing it, these 2 events are said to be independent, which means the probability of one does not affect the probability of the other. So the probability of getting that jack was 4 out of 52. The probability of getting the second jack is also 4 out of 52. So all I have to do is simply multiply those two probabilities. Again, it's 1/13 out of 113, 169. You see I'm doing it again now. Probability of a queen. I replace it, probability of a 5, so this be the same thing. Any two cards basically be the same. I just have to multiply their probabilities. Well, now I have a 5 and then a 6, and you see I'm leaving them out there. This changes things slightly. So what do I do here is I do the probability of a 5, probability of a 6. Well, what was my probability of a 5, right? The probability of a 5 is going to be 4 out of 52. But now that changes this one because I'm leaving a card out on the table. There's only 51, and it's 4 out of 51. So I simply multiply the two of them. If I was going back to the jack and the jack, probability of jack and probability of a jack, and this is called without replacement. Then you're going to do, well, the first one's still 4 out of 52. But now my second one is going to be 3 out of 51. I simply multiply those things across. That'll give me my probabilities, whatever they happen to come out to be. So you'll see as I go along here, there's only a couple seconds left in my video. I'll just talk about your general formulas. Probability of A times the probability of B is if they are independent events. If they're not dependent events, it's the probability of A times the probability of B given A occurred. So there are two formulas for independent events. Thanks.